All right, let's look at how to find the average rate of change graphically. So here we have our functions. We have our x values, so we can find our change in x, but we need to find the change in y as well. So when x is equal to -2, it looks like it's going to be right about there. So that point, if x1 is -2, y1 is 1, it looks like. Or another way of writing that would be -2 comma 0. And then when x is equal to 1, which is right there, that means x2 is 1 and y2 is 0. Where that point is 1 comma 0. And then to get that average rate of change, we'll just fill in that formula. So the average rate of change is going to be 0 minus 1 over 1 minus a -2. So I'll have a -1 in the numerator, and then this is really 1 plus 2. So that gives me a 3. So my average rate of change there is a -1/3. Okay, and visually, that average rate of change is represented by this line here. Okay, that's going downhill. And then find the average rate of change over the interval -3 less than x less than 0. So we're looking at between x equals -3 and x is 0. All right, so 1, 2, here is the point for when x is equal to -3. And so we're going to kind of have to estimate what that y value is there. It looks like maybe that that point is going to be -3 comma 1.5. And then when x is 0, so that's this point down here. And so that would be 0 comma -3. And so that average rate of change is going to be represented by that line there. Okay, and that one's going downhill too, so I'm going to expect that I'll get a negative rate of change here. So ARC is going to be equal to, we'll do the y values here in the numerator, so -3 minus 1.5 over 0 minus a -3. So it looks like I have -4.5 in the numerator and a +3 in the denominator. We could pull out a calculator and get that. That's going to be a -1.5. So our average rate of change over the interval from x is -3 to 0 is -1.5, which is what we expected with that downhill line. All right, numbers 10 and 11. I'd love you to pause the video and give those a try and see if you're understanding that concept, and then we'll come back and do them. All right, so hopefully you gave those a try. This first one is between x is -1 and x is 4. So here x is -1. So that point looks like -1 comma -3. And then when x is 4, it's going to be this point here. And that looks like 4 comma 2. So our average rate of change here is going to be 2 minus that -3. So be careful with those signs. And then our change in x is 4 minus a -1. So when you minus a negative, that really just means you're adding. So we get 2 plus 3 is 5, and 4 plus 1 is 5. And so our average rate of change here is 1. Okay, and the interesting thing is here we had a curve, so that average rate of change really is just focusing on those two endpoints. Turns out if you're finding the average rate of change on a line, that slope of the line is exactly what that average rate of change is. Okay, so it's kind of a fun thing. And then if you did the average rate of change over that interval from -3 to 1. So here is x is -3. So I see -3 comma -1. And the other side is here. So when x is 1. So here is the line that represents the average rate of change I'm finding here. And that point is 1 comma -1. So our average rate of change, you notice this line is flat. These other ones were downhill and we got a negative average rate of change. So we'll see what we get with this one that's flat. I'll subtract those two y values. So I have -1 minus a -1. And then the y values or x values, I'm sorry, are 1 minus a -3. So this is -1 plus 1, which gives me a 0 over 1 plus 3, so 4. So that average rate of change there is 0, meaning that the function isn't increasing or decreasing over that interval.